This is another example of an IP address that was given in binary, and it has now been converted into decimal notation. So this is the IP address in decimal notation. Okay, can we represent this same IP address in hexadecimal notation? Let's do that. To convert this this IP address in binary form into hexadecimal, we are going to now work with nibbles, and a nibble is equal to 4 bits. So a nibble is equal to 4 bits. So we are going to work with nibbles, right? So we are going to break this into nibbles. Okay, and 1 2 4 8 1 2 4 8 so this is equal to 11, and 11 is basically equal to B in hexadecimal. This equals 3, right? This equals 6, this equals 10, and 10 is basically A in hexadecimal. This equals this equals 13, and 13 equals D in hexadecimal. This would be 7, this would be 9, and this would be 3. So our answer in hexadecimal for this IP address is B3.6A.D7.93. So this time you have to work with nibbles, right? 4 bits. This table gives a summary of what we have studied so far. What we have studied so far is called classful IP addressing, where networks can belong to 3 classes: class A, class B, or class C. The prefix for class A is 0, for class B is 10, for class C is 110. This prefix helps the router identify whether this IP address is a class A IP address, or a class B IP address, or a class C IP address. Okay, and then we also studied that the number of bits for network in class A are 7, right? The remaining number of bits would be used for the host address, which would be 24. Remember, 7 bits plus this first bit value, which is fixed, would make 8 bits. So 8 bits, and then the remaining 24 bits are used for the host ID. Here the first 2 bits are 10, and then we have the next 14 bits used for the network ID. This makes a total of 16 bits, and the remaining 16 bits are used for the host ID. Here we have 3 bits which are used for prefix. Then we have 21 bits available for the network ID, which basically means what? 21 plus these 3 bits would be 24 bits, and the remaining 8 bits in the IP address are going to be used for the hosts. This table provides the same summary but in a different form. So for example, what we are saying here is that if we take a look at the first octet, meaning the first 8 bits, in an IP address, in decimal notation, so these 8 bits have been converted to a decimal value, right? And if we find a value between 1 to 126, then this is a class A IP address. So if you find an IP address written in decimal notation by taking a look at the first octet or the first 8 bits converted into decimal, so for example 73.65.95.88 is an IP address. When we take a look at the first value, this value is going to tell us whether this is a class A IP address or not, and this is a class A IP address because in class A the starting octet can have a value between 1 to 126, right? So this value 73 is between 1 and 126, so this is a class A IP address. Okay, if the starting value is between 128 to 191, then this is a class B IP address. And if the starting value is between 192 to 223, then this is a class C IP address. Okay, let's solve these few IP addresses and try and find out which class they belong to. Okay, so this first one is, the starting octet is 157, and 157 would be a class B IP address because the value for class B is between 128 to 191, right here, 128 to 191. So this is a class B IP address. 22 would be a class A IP address because the starting octet has a value between 1 and 126. This is starting with 1, right? So this would also be a class A IP address. This is starting with 128. Is starting with 128, and 128 means what? This is a class B IP address. This is a class B IP address. And how about this one? This is starting with 213, and anything between 192 to 223 is what? It is class C. And this one is starting with 192. So anything starting with 192 is what? It is class C. So this is also class C. Okay. Now let's just go one step further. For this IP address, what is the network address? What is the network address? Remember, this is a class B IP address. In class B, the first 16 bits are reserved for the network address. So the first 16 bits would be 8 plus 8, 16, right? 157.65. So this would be the network address. The remaining bits would be the host address, and we are going to set them to 0, right? This is just a convention. So we just set the host bits to 0, right? And so this is the network address. How about this class A IP address? Remember, what is the network address for 22.179.36.44? So this is a class A IP address. In class A IP address, the first 8 bits are reserved for the network, right? So 22 would be the first 8 bits, right? And the remaining 24 bits are all what? They are all host bits. So we're just simply going to set the host bits to 0. So this would be the network address. How about this one? This is starting with 1. So this is a class A IP address, and once again in a class A IP address, only the first 8 bits represent the network. So 1, and the remaining bits are for the host. So we are going to set all of these to 0. How about this class B IP address? How about this one? 128. It is beginning with 128. So this is a class B IP address, and for class B, the first 16 bits are reserved for the network, right? So the first 16 bits would be what? 128.55. 128.55.0.0. Okay. Let me just create some space. So for this class C IP address, the network address will be, since this is beginning with 213 and this is the class C IP address, so the first 24 bits are reserved for the network address. So our network address would be 213.55.60, and the remaining 8 bits are the host address, and the host address we are going to set to 0. Okay, how about this one? This is also a class C IP address, so the first 24 bits are going to be reserved for the network address, right? So the network address in this case would be 192.31.58, and this is the network address, and the host bits we are going to set to 0. So the router can find the network address by using the prefix, right, which is 0 for class A and it is 10 for class B, and it is 110 for class C. And based on that, the router can tell this is a class A IP address or a B IP address or a class C IP address, and then it can find out the network address through that. Our way of doing it is that we are going to take a look at the starting value, right, whether this is 157 or this is 22 or this is 1, and then we are going to judge whether this is a class B IP address or a class C IP address or a class A IP address. Okay, for a class C network, this is the prefix, right? So 3 bits, and then we have the remaining 21 bits for the network, right? So basically this is always going to be fixed, and this is the part where we can have different values, right? So how many possible networks are there? How many different class C networks are there in the world? Well, the answer is 2 raised to power 21. Okay, and how many hosts can we have on each class C network? Since we have 8 bits to assign our hosts an IP to assign the host address, therefore the maximum possible host addresses would be 2 raised to power 8, which is 256. But we always subtract 2 from this, right? 256 minus 2 would be 254. Why do we subtract this 2 from these 256 addresses? Well, when host bits all have a value of 0, right, this is basically the network address. Remember, the network address we write as something like this, 212.36.77. remember, this is a class C IP address because it is beginning with 212, and the first 24 bits are going to be used for the network. Actually, these 3 bits are fixed, right? So these won't change, but these 3 plus the 21 network bits is basically 24 bits. So the first 24 bits are reserved for the network, right? And then the last bit is always set to 0, right? So this would be a network address. When the host bits are all set to 0, then this is the network address. Therefore, one of the values that these 8 bits can have is all zeros, right? All zeros means what? That this is when the host bits are all set to all 0, that means this is the network address. We're trying to specify the network address. And when the host bits are all set to 1, so all 8 bits have been set to 1, then this is a special address. This is called a broadcast address. This is called a broadcast address.